Hello everyone, in this video we are going to look at different built-in data structures that we have in Python. A data structure is used to bundle data together. In Python we have different built-in data structures like lists, tuples, sets and dictionaries. Of course, you can consider strings also as built-in data structures. We don't find these data structures in C++ by default, but in Python we get all these out of the box and we can directly use them in our programs. So let's look at these built-in data structures one by one. Let's start with lists. A list is an ordered sequence of items or elements. A list can be thought of as an array, but lists are far more flexible than arrays because arrays can hold elements of only same data type. But whereas in list we can have elements of different data types. For example, here we have 100 which is an integer and 20.25 which is a floating point number and PurpleLane is a string. This is perfectly valid in Python, but whereas in C++ we can't have different types of data in the same list or same array for that matter, right? So Python lists are far more flexible than arrays, right? Now let's talk about the ordered sequence of items. Since list is an ordered sequence of items, these are indexed starting with 0. So the first element in this list will get the index 0 and the second element will be at index 1. The third element will be at index 2. This is similar to what we have seen in case of strings. And also observe that these elements are bounded by square brackets, right? And the elements are separated by commas. So a list is bounded by square brackets. I'm emphasizing this because we are going to use different types of brackets for different data structures. So for list we are going to use square brackets and all the elements are separated by commas. Now since this is an ordered sequence of items, we'll be able to index these elements. So the first element will be at index 0, second element will be at index 1, third element will be at index 2. Now comes the interesting part. You can even access an element at a particular index. So we have 0, 1, 2 as the indices of this list. If I want to access an element at index 1, I can do so like this. So observe that we have the variable a followed by the square brackets. Within that we have the index position, right? This will print the value which is at index 1. Here we have 20.25, so it prints 20.25. You can even get the other elements by indexing. For example, if I want to get the 0th element which is at index 0, I can give something like this. Or I can get the last element which is at index 2 like this. You can also get the last element by having the negative indices like this, right? This is all similar to what we have seen in strings. Similar to strings, here also we'll be able to index the list. Now you can also alter a particular element in the list. For example, let's say I want to change, let's say these are the indices 0, 1, 2 and I want to change the value at index 1 to 150. So I want to have 150 in this index. So finally the list should look like 100, 150 and PurpleLane. So after changing the value at index 1, the list should look like this. So what I'm essentially doing is I'm altering the value at index 1, right? This is perfectly valid in Python to alter an element in list. So lists are mutable. That means elements of a list can be altered. So for example, let me show you that example here. So this is how I change a particular value at an index. So here I am assigning 150 to the index 1, right? And when I print the list A, it looks like this. So 150 is here, 20.25 is no longer here, right? So you can directly assign a value to a particular index. That means you can change the elements of a list seamlessly. So lists are mutable. Now, since these are the indices 0, 1, 2, you will be able to access the elements from left to right or from right to left using the negative indices, right? You can access any element in this list at random. But if you try to access an element which is out of this index, Python interpreter throws an exception. For example, here we are trying to access an element which is at index 4, but the maximum index that we have in this list is 2, right? The index 4 is not there in the list. So what Python tries to tell you is that you are trying to access an index which is out of the range. So there is an exception called index error that Python interpreter raises when it encounters this type of errors. So it is illegal to access an index that is outside the bounds of the list. So you should watch out for such exceptions when you are accessing the elements of a list using indices. Now let's look at the next data structure called tuples. Tuples are also an ordered sequence of items just like list. Here is an example of tuple where the elements of this tuple are same as that of list that we have seen in the previous slide. Now observe that these elements are bounded by parentheses, right? These are called parentheses. This is for tuple, but whereas for list we use square brackets, right? And the elements are separated by commas. Since this is an ordered sequence of items, these elements are also indexed. So the index starts with 0, 1, 2 and continues till the end of the tuple, right? Since we have only 3 elements here, the last index will be 2. And we can also access a particular element given its index. So if I want to print the element at index 1, I can do so like this. Observe that there is a square bracket after the variable name, right? This will print 20.25, which is at this index. Now an interesting thing about tuples is that unlike list, you will not be able to change a particular value given its index. For example, here we are trying to assign 150 to the index 1, which is not legal because tuples are immutable. That is the only difference between tuples and list. And of course the syntax is here in case of tuples we use parentheses, but whereas in case of list we use square brackets, right? The only difference between list and tuple is that tuples are immutable. That means you will not be able to change a particular value given its index, right? You can think of these tuples as constants. Once you have defined a tuple, you will not be able to change a particular value in that tuple, right? So it says tuple does not support item assignment. So this is an error or an exception called type error, where it says the tuples does not support item assignment, right? This is the only difference that we have between list and tuples. Now let's look at the next data structure called sets. A set is an unordered collection of unique items. Now this is interesting. Let's look at an example and come back to its definition. So here is a variable called s, which is assigned with a set. So in this set we have different elements and this set is bounded by curly braces. These are curly braces, right? Remember, for tuples it is parenthesis, for lists it is square brackets, and for sets, this is curly braces, and all the elements are separated by commas, right? So this is the syntax for defining a set, and when you print this, now this is where things become interesting. Now if I want to print the set S, it will print all the values which are unique. That means it won't consider duplicate elements if there are any. So in this case, there is 30 which is repeating and 4 which is repeating. So it will not consider these two elements, and it gives you only those elements which are unique. And also, set is an unordered collection, so there is no indexing. Indexing is not possible in case of sets, because in case of sets, order is not maintained, so we can't have indexing for sets. So you will not be able to access values using indexing. This is not valid, right? So you will not be able to access the elements of this set like this, right? So when you try to access the element using the index, it says type error, and it says set does not support indexing, right? We'll look at how to access and how to use these sets and different types of operations that we have in sets in the later chapter. One interesting thing here is these sets are nothing but the mathematical representation of sets. So we have learnt about set theory in mathematics during our high school. So if you remember, we used to draw some Venn diagrams like this and find union and intersection and all, right? So this is the union of these two sets, so where A and B are union, and we used to find A union B, A intersection B, A difference B and all, right? We are going to look at all these operations on these sets also, right? This is pretty much the same thing that we have learned in high school mathematics called set theory, and there are numerous operations that we can perform on these sets that we'll look at in the later chapters. Now let's look at the next data structure that we have in Python called dictionaries. Dictionaries are also an unordered collection of values, but these values are represented in key value pairs. The dictionaries are extensively used in Python programming. These are extremely important that you will encounter dictionaries in almost every project that you come across in this course. Not only in this course, but when you work on any other project, you will definitely come across these dictionaries. So it is extremely important to understand the working of these dictionaries. So let's look at an example and let's come back to the definition later. So here is an example where we have variable d which is assigned with this dictionary. So in this we have two values which are separated by a comma, right? And these values or elements are enclosed by curly braces. These are also curly braces, similar to what we have seen in case of sets, but the difference is we have this syntax. So each element is like this. So let's look at each element now. So here we have A followed by a colon followed by apple, right? In this is the key and this is the value, right? And in the second element we have this B which is our key followed by this colon followed by the value. So this is the value. So you can think of this dictionary as a table. So there are keys and values. Here the key is A and the value is apple, and the next key is B and the value is ball, and you may have other keys also, C for cat and so on, and all these will be like key and value pairs. So if you are aware of hash table, this is that, right? So in Python, dictionaries are same as hash table data structure, where we have key and value pairs, right? And also observe that this is an unordered collection, so there are no indices. So 0 1 2 3, these are not there, indices are not there. You can access the value directly by looking at the key. So here is an example. So if you want to access any value, you can access directly by considering the key of that particular value. For example, if you want to access apple, you can just give the key A, corresponding key A, like this, right? You can even give B in the dictionary so that it will print you ball. And if you try to print a key which is not there in the dictionary, then it will throw a key error. So for example, here we are trying to access key called C, which is not there in this dictionary, right? Clearly C is not there in this dictionaries, and you are trying to access C, so it will give key error, right? So this is how you define and access elements in the dictionary. We'll look at different methods to perform operations on these built-in data structures in the later chapters. So in this video, you have learnt about 4 built-in data structures like list, tuples, sets and dictionaries, and you also learnt about how to define them, how to access them, and we have also understood what type of errors Python interpreter can give you in case you are trying to access an illegal element.